Your presenters today will be Fyodor, who has been the author of the open source Nmap security scanners and authored it in 1997 and continues to coordinate its development, as well as David Fifeld, who's been doing Nmap for several years, and he does the maintenance of the NCAT and Nmap scripting engine.
Great. Thank you. All right, can you guys hear me in the back? Woo! All right. Well, I'd like to thank you all for coming. I know there are 10 other talks you could be at right at this time, including one of a guy who likes to pretend he's a girl on social networks. So I'm glad you decided on ours instead. He is a girl. I guess so. So I would like to start this talk with a couple questions for the audience, actually, that'll help us tailor it to the right level and not cover anything you already know. So who here already knows about and has used the Nmap security scanner? All right, all of you. We'll skip Nmap for dummies. And who here has already read the 40 pages of NSE documentation that we included in the conference CD? Huh. Anybody? All right, well that's okay, because we're going to cover the highlights of NSE and all the neat things you can do with it, and I'm hoping that that may inspire people to actually try it yourself and maybe even try your hand at writing NSE scripts. I want to mention that all the features that we're going to show off today will work for you on either Nmap version 5.35 DC1, the DEF CON release that we did earlier this month, or 5.35 DC18, which is our latest Subversion release. So let's get started. I'm going to begin with a quick outline to let you know what to expect from this talk. We're going to first go into a brief introduction on what NSE is, what you can use it for, how to use it, and then we're going to actually show you how to use NSE with some large-scale demonstrations. In the first one, we're going to scan millions of hosts of a large corporation and show what sort of information you can gather for that. And then David is going to show you in a completely different way the power of NSE, although his also involves scanning millions of hosts. After that, we're going to look at writing your own NSE scripts. Then we're going to do a neat demo for you, and then show off some Nmap news and developments that I'm excited to show. And then we'll take any questions that you might have. So with that out of the way, let's begin. The Nmap scripting engine is one of Nmap's most powerful and flexible features. It allows users to write and share simple scripts to automate a wide variety of network tasks. For example, enhanced network discovery, vulnerability detection, and even exploitation you can do with NSE. And the nice thing is that you don't have to write all these scripts yourself. They're packaged. We have 131 of them packaged with Nmap that you can use that solve a wide variety of networking tasks. I feel that NSE really completes Nmap's scanning mission. We already had host discovery, where we would scan a network and try and figure out which machines are up and available. And we put in OS detection, which allows you to figure out what operating system is running on those machines. We have port scanning followed by version detection, which lets you look at all the services those machines are offering and what application versions are available. And then NSE is sort of the glue which binds all of that knowledge detected by Nmap together and lets you use that to further interrogate the network in whichever ways you have desired. So we're going to look at a quick example on this slide. I don't know if people can read it in the back, but I'm going to go over what it says anyhow if it's too small. We're here scanning a machine called scanme.nmap.org, which is a machine I run for people who want to test Nmap, see how it works, do some scanning. As you'll see later in this talk, I'm not shy about scanning other people's networks and machines, so I feel it's only fair to offer one of my own for people to scan me back. We also use the -A option, which is the only option you need in order to enable a number of advanced features, including OS detection, version detection, and the Nmap scripting engine with its default set of scripts. Now the output you can see here, I think people are going to be pretty familiar with if you're an Nmap user, most of it. But we're just going to look at the parts which are related to NSE. This first one is under the OpenSSH port. We see this SSH host script, the host key script, which basically tells you what the hash of the server's SSH cryptographic key is for when you're connecting to it. Now, such a script might be useful if you were scanning your network and maybe wanting to detect invalid keys that might be a signal of a Trojan SSHD or another sort of attack. But what I actually find it more useful for is as a unique identification for a host that's not related to its IP address. So for example, I may scan a machine and find a lot of information about it and be wanting to further interrogate it more the next day. But the next day it might be totally gone, changed to a different IP address because it used a DHCP server to configure itself. Well, with SSH host key, you can just scan the network again, find the machine with that same host key, and you know that's the same one that you've already been, working on. Similarly, if I scan a big network and I see several machines which are all configured very similarly, I might wonder, are these all different hosts with different instances of the OS and potentially different application versions on there? Or is it just one host with a bunch of IP aliases listening on its interfaces? Well, SSH host key, again, you can see if each of those IPs has the same host key, and that'll give you a good idea of whether it's fundamentally the same host. If you look a bit further down, you see the HTML output. We have some script output there. The first one is the super simple one. HTML title simply connects to the web server, grabs the root document, and gives you the title and prints it out. Very simple, but it can be useful in the context of your scan to see this information. The next one we see is called HTTP methods, which looks at the methods supported, get, post, whatever, and tells you if there are any that are kind of risky. In this case, it says, well, the trace method is a little bit risky, and here's the URL that gives you details. If it had seen like the delete method or the put method, then it would have raised bigger alarm bells. So these are just a few scripts, and they're pretty trivial ones, although they give you useful information. But we have a lot more. And I want to introduce you to our NSE full list to give you an idea of the breadth of tasks you can accomplish in NSE. So one of the features we have is a site called the NSE Documentation Portal, which you can reach at any time at nmap.org/nsedoc. And it gives you a bunch of information about all the scripts we have. Right now, I just want to show you the categories pretty quickly so you can get an idea of the different sorts of tasks you can automate. We have the auth category. That's for authorization-related scripts, particularly like brute forcers for protocols and the like. For example, we see here AFP brute, which is a brute forcer for Apple's file sharing protocol. The next category is called default. That's the scripts. We've personally curated this list to try and find the ones that we think would be most useful to run by default. That means it shouldn't be crashing networks and services. It shouldn't look like an attack to the remote network administrators. And it actually has to give generally useful information. We don't want to spam your Nmap results with a bunch of information that may be useful in some real obscure case, but not for most users. For those, we can have a different script that you can just run on request. The discovery scripts is an area where Nmap, of course, really likes to shine. Its basic goal is network discovery, to tell you what's on the network. And for any of these categories, you can actually click on the link, and you can actually see all the scripts we have in that category. So for discovery, we have pages and pages of different scripts to get you information from various databases, IRC servers, websites, DNS. It goes on and on. We have DOS, a category for denial of service attacks. We don't have many in there. Exploit category for exploits for vulnerabilities. Fuzzers, I think there's just one of those. Then intrusive and safe, those basically are just a classification category for how intrusive a certain script is likely to be. The ones that are likely to be pretty safe to run in general, we put in that category. But if it might cause problems in some situations, might crash things, might be perceived as an attack, you see that it's in the intrusive category, and you can look more carefully at why that is before you actually run it. We have malware detection scripts in the malware category. Nmap was one of the first to detect the Conficker worm remotely last year and got a lot of attention and downloads from that. We have version detection category. Our version detection system now has more than 6,000 signatures in it, and so it can detect all sorts of things, but there are some protocols that even our version detection isn't powerful enough to solve. Some that actively try and hide themselves on the network to make them harder to find. Things like Skype is an example where our normal version detection can't find it, but we were able to do it in an NSE script. So through this documentation portal, that's a great way to go through the scripts that are available and find the ones you need. Now the next step is once you find a script, you want to find more information on it. And so I'm just going to show one quick example here. It's a script called NFS-LS. If you want to find more information on that, you click on it and you get this special page, which starts out with a way to download the script source code so you can see exactly what it does. Then it follows with a description, a quick summary of what the script does. This one is basically like LS for NFS shares. So it shows you which shares are available on the remote NFS server and which files on those shares are offering and under what permissions. And so we see the script arguments it can take, like a max files to say only show me the first 5 or 10 files. You know, the time, do we want to show just the modification time or the access time or the change time? And a few arguments that actually come from the RPC library, which it uses in order to get its data. Those, even though they're not in the script specifically, those arguments can still be useful because they're used by libraries which are used by the script. We have an example of how to use it, and then an example of what the output looks like. You can see here, he really did try and make it look like a directory listing you might get with LS. It tells you which of those categories that we talked about it's in. This one's in discovery because it's finding more information from the network, and it's in safe because it's unlikely to cause network outages or other problems. So that's just a real quick overview of our documentation portal and where you can go if you want to find out what scripts are available to use. And the number of scripts we have has actually been increasing pretty rapidly. I have a chart here, and you may not be able to read the labels from far back, but basically it's each year on the 1st of January and the 1st of July, how many scripts that we had available at that time. And it took us a while in order to figure out what, how our review process would work and to develop all the infrastructure. So growth was pretty slow at first. But lately it's been growing up much faster, as you can see. Even though we've been working on NSE for 4 years, in the last year it has more than doubled in the number of scripts it contains. And I won't be surprised if it has doubled again by the time Blackhat rolls around next year. So that's the system, NSE, what it does, how it works. But I think what can be really useful is to kind of show how it can work in a large-scale situation, how it can find useful data for you. And to do this, I want to show off a number of scripts that we have for dealing with SMB and MSRPC protocols. Now these were actually written by a fellow named Ron Bose, who basically spent months digging into MSRPC and RPC and how those protocols work. I don't really wish that on anyone, but it's nice that he was able to do it. He contributed 13 scripts, and so it was quite a gift to the Nmap community. We have informational ones for OS detection, SMB, getting the server stats, system info, security mode. We have enumeration scripts where it connects to the remote server and tries to enumerate data like the users, the domains, the groups, processes, sessions, and shares. And then we have 3 more intrusive scripts that go in, like for example SMB brute, tries to do brute force authentication cracking over SMB to try and find the usernames and passwords. SMB check vulns will do vulnerability checks for a number of remotely exploitable MSRPC bugs, and SMB psexec lets you execute processes on the remote system for things like dumping the password hashes or starting a remote display server on the system. And so I thought about this a lot, and I had these great new scripts that Ron created, and I thought, well, I really want to test them out. And I don't have many Windows machines on my home network, so I wasn't going to really try them. I couldn't find out much information from that. So I thought, well, who would be a good target for a large-scale scan of this sort of a script? Well, it's their own darn protocol. So you would think if anyone could secure it, Microsoft could. And I was kind of interested to see how they would decide to secure it. Would they block all the SMB ports? Would they very carefully lock down the individual services to prevent you from getting much information? How would that go? And so I did the scan, and I have reported this. I actually did the scan last year and reported the data to MSRC, so I hope they fixed it. If not, it's going to be some late nights in Redmond coming up. So let's see how this scan worked. Step 1, find the target IP addresses. We scanned I used Whois on the Aaron database, typical methods, and found more than 1 million IP addresses assigned to Microsoft and decided to scan them all. I decided to start with a broad version detection scan, and the scan could have been more intrusive and more inclusive, but I decided first we'll start with a medium to light scan to kind of figure out what's going on the network, what is where, because a larger scan would take longer and more likely to raise eyebrows. So here's what we did. I said -T4 to be more aggressive on timing, scan the 50 most popular ports based on our empirical data, do version detection, OS detection, a couple OS detection optimization flags, set the host group to 128 because that scans more in parallel to make the scan quicker, set a host timeout of 10 minutes so we don't waste too much time on one extra slow host, do the output to files, tell it where to get the input Microsoft IP address list from, and let it chug away. Now there was a time when this sort of scan could take a month or more for Nmap to run against 1 million IPs. And to make it faster, Nmap has a wide variety of performance optimization flags you can tune, but that was a real pain in the neck. And now I'm happy to report that Nmap has gotten a lot smarter over the years in its algorithms to do large scans much more quickly. So this scan, it finished in about 26 hours, about 1 day, scanned all the IPs, and found 74,293 hosts up. So I could have even tuned it more to make it go faster, but it's not like I have to watch it running, and making it too fast, again, raises more notice on the network. So from that, let's take a very quick look at the results. So I'm going to switch to a larger, Let me get to the terminal window again. I think I moved it. Yeah, I'll get it. Yeah, I see it. Okay, so here's the larger of the terminals, and we're going to so we look at this giant file, and it's kind of intimidating just in its length in general. It's 361,000, more than 1/3 of a million lines long. So if I was going to go through this whole file with you, we'd be here all night and still only have a small fraction of it. So a little trick I like to do when I do these large-scale scans like this to look at the results is I have a little command that, it's basically just simple Unix shell command that basically finds all the open ports and shows us which services are the most common on the network. So here we see the most common is 4,745 examples of IIS-6, and then more IIS-6. we have to give them that they're at least eating their own dog food here in running a lot of Microsoft stuff, although they do have a lot of Apache. And what I find more useful than actually looking at the most common services is to go down to the bottom and look at the more obscure stuff, because that's where you find the less common services that might be more easily exploitable than the things that everybody runs lots of. And on the network I found all sorts of little printers and teleconferencing systems and various little devices. I could log into like the admin interface of some printers and see their toner level, and that was fun, but it kind of gets away from our main goal, which was to show what our SMB scripts can do. So we're going to avoid this sort of network voyeurism and instead look at, oops. Instead, we're going to look at how the SMB results turned out. So I did the big scans and I looked at how it worked, and it turned out that the vast majority of Microsoft networks just completely blocked the Windows ports from their networks, such as 135 and 445. And this is probably something, other enterprises and businesses should take note of. If Microsoft feels that it's unsecurable and should be blocked, then you probably would want to as well. But notice I said the vast majority of their networks blocked them. Not all of them did. There were dozens of machines that had 445 open, for example, which is the more common of the more modern of the SMB ports. So I did a new scan, and here we'll look at the scan command. The important thing we really care about is this -- script equals. That says we want to do an NSE scan, and here's the list of scripts that we run, including enum domains, enum processes, basically all of the ones that were not super intrusive that Ron wrote. So syntactically, I could say SMB-brute star, and then or SMB-star and get all of them, but I don't want scripts like SMB brute. Even I'm not crazy enough to brute force attack Microsoft's passwords and then present about it at a big conference. So instead, I just used the less intrusive ones to see if we could still find interesting information. Now, before we look at the results, I would like to get some commitment from the audience. Who here thinks that Microsoft's SMB was completely secure? Not even the Microsoft people are raising their hands. Well, let's take a look. Maybe Microsoft will surprise us a little bit and be very well locked down. So this time we're going to look at another file. This is the one from that new scan I mentioned. And we don't have time to look at it in a lot of depth, so I'll just go to one of my favorite machines here. We see, first of all, that it has 976 closed ports. So instead of doing the default filter, default deny, and saying only allow access to the ports that we want to, they've set it so that we can access all the ports and see whether they're open or closed. And then they've explicitly banned a few ports like telnet we can see and auth we can see. And so instead of default deny, they did default allow and then blocked some ports. So we'll take off a couple security points for that. Then we'll go down a little bit, look at the open port lists. You can see there's a huge number of them. And really, when you want to secure your systems, you want to try and minimize the potential avenues for attack. And so in this case, we're going to have to deduct a few more points for having so many open ports. Now, we finally get to the host script results you can see at the bottom. This is the NSE stuff that we were talking about, and we can see whether those managed to find any interesting information. So SMB enum shares is the first one that reports. We see the anonymous IPC share, and then we see some restricted shares for admin, net login, C drive, and D drive. Now they are restricted, but I'm not sure that it's still best practice to share your drives across the internet. And if we had used the SMB brute script, maybe we could have found some passwords there. So we have a few more scripts. And then we get to SMB enum users. This is the one that tries to enumerate all the usernames on the machine. And we can see that it was actually pretty successful. Here's an administrator account here. And we've got this guy, Richard. He's the boss man, is his username. And so you can see you get the username as well as some supplemental information there. Let's see, there were a few other ones that I wanted to highlight here. MSB50net is the Building 50 networking team. So again, you get a little more, since we used the script in verbose mode, we get more information than just the usernames. Even things like, this one, the password does not expire, normal user account. This one's called not a guest, exclamation point. Here's one. It says support Microsoft Corporation, Redmond, Washington. And my favorite, though, has got to be the T-shirt ho. So yeah, a lot of information you can find with these SMB scripts. And I would like to mention that, like I said, it was actually Ron who did all the work writing them. All I did was just point them at Microsoft and pull the trigger. And Ron actually, I think, are you here today, Ron? Right here. Awesome. Let's give Ron a round of applause. All right, so now that's one large-scale example of SMB, of NSE scanning. And I'm happy to report that Nmap's co-maintainer, David, now has a great example of other types of fun things you can do with the scripting engine.
Thanks, Fyodor. So have you ever had sort of a simple idea that just started growing and growing and growing and grew into something, in this case, kind of great? That's what happened to us with one of our NSE scripts. We have a script called HTTP favicon. It's a pretty simple idea. You guys know what a favicon is. We open up the web browser here. It's this little icon that appears next to the address in your browser. You can download that and hash it and collect a bunch of these hashes and build a database. And then later on, you can look things up in the database and try and match patterns with the icons. The idea is that a lot of web applications have default icons. So you can connect to a website, and then this script will come back. It'll download the icon. It'll hash it, and then it'll say this site is probably running Joomla, or this site is probably running MediaWiki, or something like that, which is interesting information for someone testing a website. So this script was submitted. It was a guy named Vladko Kosturiak, and I've heard that he may be in the audience. Are you here?
Oh, there he is.
There he is. All right. If you didn't know, today is Buy an Nmap Developer a Drink Day, so you're right on time. So we got the script, and it was a great script, and it did everything right. Just one problem was that the database was kind of small. It only had about a dozen entries, and we weren't sure how good they were, how current they were. We wanted to really back it up and have a quality database to ship out to Nmap users. Whenever we build a database in Nmap, we really like to back it up with real results. And also, we just like to do a lot of scanning. So that's kind of an excuse for us to build our databases. All right, so what are we going to do? How are we going to collect all these icons? Does anybody know of a tool that you can use to scan millions of internet sites? A tool that is scriptable, perhaps? Okay, so it's an obvious choice for us. We're going to do this with Nmap, and it's a good choice for an NSE script. So I wrote this script called favicon survey. If you download Nmap, you're not going to find this script because it was sort of a throwaway script just for this survey. But I wrote this, and it does just what I said. It connected to a bunch of websites, download the icons, hashed them, build a huge database. Let's compare writing this as an NSE script to writing it as, say, a custom Perl or Python script, which would also be a viable option. if you're writing a Python script or something, it's easy to write code to connect to a website, download the icon, do the hashing and everything, and run it against one site. But then you think, to make this really fast, I've got to parallelize it. And then you've got considerations like, what if the site requires SSL and things like that? All of that is built into NSE. You get the SSL for free, you get the parallelization for free, so it's really a good fit. We had to decide which hosts we're going to scan. There are some advantages to doing just random IP addresses because you'll get people's home cable modems and things like that, which are useful for fingerprinting. One problem with scanning IP addresses with HTTP is that you don't always have a host name, and sometimes that's required to access certain resources. So we decided against that, and we did a big survey of just the external links of some large web databases. So from the Open Directory project, we got about 5 million links. We took the 4 biggest Wikipedias and took all their external links. Obviously, there's going to be some overlap. We put it all together, and we had 8 million unique domains. An Nmap developer named Brandon Enright did all this scanning. As I recall, it took a few days. And in the end, we ended up with almost 1 million icons. About 80% of those were image files. About 20% of those were non-image files and error pages and things like that, which also can sometimes be useful for fingerprinting. Now, this is great. So we did all our results. We looked at the top 50 or so icons. We went and verified them manually. And we built a database, and that's what you get if you download Nmap now. You'll get a database of these top icons from this huge survey. But to me, it's sort of disappointing to do days of scanning and get gigs and gigs of data and end up with a 50-line data file. So we tried to think of something more creative to do with this. We ended up doing a second scan of the top 1 million web domains as published by Alexa. They publish their top 1 million domains, and then they also publish a number that they call reach, which is just sort of a measure of how many people visit this site in a day or a week or whatever it is. And so we had the idea, we'll just get these icons, we'll pack them together into a graphic, into a visualization, make the size proportional to the reach, and just see what it looks like. So here we've got a small example, but I've got something even better. If you go to nmap.org/favicon, if you're interested in exploring this data set and learning more about this scan, because there's a lot of interesting technical information, you can go to this website, and we built this really nifty zoomer and scroller so you can kind of explore this picture. So let's take this and kind of zoom in on a portion of it. All right, so you can see you kind of scroll around and things like that. But what do we see here? This should be familiar to everyone in the audience. All right, let me apologize. Some of these icons are a little PG-13, but we've got nmap.org here, some cute little Mario mushroom. We've got little Tux penguins. So it's kind of fun just to browse around this and see everything that you can see. So I encourage you to kind of check it out. And if you want to see a certain icon, if you suspect that your site may be in this top 1 million, there's a little lookup function. And it'll find it and zoom in on it, as if that was a hard icon to find, because obviously Wikipedia is one of the biggest sites on the net. All right, no examples right now. We don't have time for that. But what I'd like to do is... so we like this graphic so much that we decided to turn it into a physical poster, which is what we have here. So here you've got the whole thing. You can see the big graphic. I mean, a lot of things stand out here. Google is easy to see, and things like Facebook and Yahoo and YouTube. But here's this, and we've got the top 70 sites identified and classified here, and just some further information about the scan. This is a really swank poster. It looks great in a living room. There are only 15 of these posters in existence. This one happens to be signed and numbered, and we're going to give it away right now to whoever can win the icon identification contest. So real quick, someone near the front, hopefully, who wants to participate? Raise your hand. All right. I'm going to pull up an icon here, and you got to tell me what website or project it belongs to.
And don't yell it out.
Yeah, the comma is supposed to be there. Okay, this icon right here. Do you know what that one is? You got it, all right. So here. Thanks very much. I'll bring this down here. I'll bring this down to you, and Fyodor's going to continue on, talk about writing NSE scripts.
Oh, the answer was OpenBSD.
There you go.
All right. Well, that was certainly a neat and creative way to use the Nmap scripting engine. Can you guys still hear me? How about now? All right, good deal, thanks. So that was a nifty and creative way to use the Nmap scripting engine. But basically, in all three of these examples so far, what we've been talking about is how to use NSE and the scripts which come with it, which is certainly very valuable in and of itself. And most casual Nmap users will never go beyond using the scripts that come with Nmap. But let's be honest here. Any script kiddie could do that. What happens if you're the network task you want to perform, we don't already have a script to do that? Or what if we have a script and it doesn't do exactly what you want it to? Well, this section is going to show you how to solve that problem and some of the benefits you can get by writing your own NSE scripts. And the good news is that even if you don't consider yourself a particularly great programmer, we've tried to make it as simple as we could to build these scripts so you can do it quickly, even for tasks that you may only want to do once or twice. So what we started with is a nifty little language called Lua. And I have the main book, Programming in Lua, here, which is a great book. And it's a simple enough language that only the first 80 pages document all of the syntax and grammar of this language. And so I want to show you a very brief introduction to Lua and the reasons why we chose it. Like I said, it's very easy to learn. If you know other scripting languages like Perl or Python, or even languages like C++, a lot of the syntax for looping and variable declaration and the like is very similar. It's tiny to embed. The book says that the complete distribution, source code, manual, plus binary for some platforms, all fits comfortably on a floppy disk. For those of the young people in the audience, a floppy disk is sort of... yes, it's kind of between punch cards and flash drives in the technology range. So being small is very important to us, because we don't want to bloat Nmap downloads with some gigantic language. Also, it was important to us that it be widely known, used, and debugged. It was created in 1993 and still actively developed, so we knew it had a good track record that we're not going to start with some brand new language that then they're going to stop developing or, give up on. It's best known for its use in the game industry with games like World of Warcraft and Crysis. But it's been taking a real strong foothold in the security community lately. Nmap can use it for NSE. Wireshark can use it for its protocol dissectors. And Snort 3.0 has a Lua interpreter. So by learning this one language, you can actually apply it to a range of popular security tools. One holdout from the Lua bandwagon is Metasploit, which is still in Ruby. But every time I see H.D. Moore at conferences like this, I talk his ear off on why he should change to Lua. I think that's why he's been avoiding me lately. A few other reasons: it's extensible. So instead of using Lua's default socket and networking code, we hooked it to Nmap's fast parallel networking libraries. It's safe and secure. Take the example of Wireshark with their protocol dissectors written in C. Yes, it solved the thing of allowing a lot of different users to contribute dissectors for an enormous number of protocols, but a huge number of them turned out to be insecure with bugs like buffer overflows and format string vulnerabilities and things that are specific to languages like C, where you do your own memory management. It's portable, Nmap, you may know we distribute binaries for Windows, for Mac, for Linux, and it works on the BSDs, on Solaris. And we needed a language that works on all of these machines too. There's even an Amiga port of Nmap for people who are into that. And Lua works on all of the platforms we wanted to support. It's also an interpreted language. So if you make a mistake in your code, you can just change it and rerun Nmap, and you don't have to worry about a bunch of makefile steps and compiling things. So that's Lua itself. Now we'll look at what NSE adds to Lua in order to make it more effective for network scanning. We have protocol and helper libraries. The idea is that we want Lua to be easy to use, and so you can do things like make MSRPC queries and HTTP GET requests without getting bogged down in all the details of handling the specific protocol. So we have libraries for DNS, HTTP, MSRPC. We have a packet library for constructing raw packets, SNMP. David's going to talk about the username and password database a little later. Basically a bunch of scripts that are optimized for writing network discovery tools. We have protocol brute forcers. One problem you sometimes have is you write a nice script that exercises a certain protocol on your target machine, but it requires a username and password. Well, with our brute forcers, you can more efficiently discover that username and password so that your script can continue. We have SSL, as David already mentioned, and we have a dependency system so that if we scan Microsoft and do SMB enum users, if we had done SMB brute as well, it would have taken that user, it would make sure that the username script runs first, and it would take those usernames and use them to brute force the passwords. So that's basically the nuts and bolts of what NSE is in terms of its infrastructure. I think now is a good time to get a little bit more concrete in things and actually look at the source code for an NSE script. The one we're going to look at is called RPC info, and it basically does what the name implies. People who've been doing pen tests for a long time have kind of become accustomed, I think we have, to basically you see the port 111 RPC bind open on the system, and then in another window you do RPC info -p target name to get the list of RPC ports, services, and port numbers available on that machine. Well, the feeling was, wouldn't it be nice, even though that's not too much of a pain, when you have thousands or tens of thousands of machines, it is a pain. Wouldn't it be nice if Nmap, if it detects the port open, could automatically do that for you and place the results right next to that port 111 so you have everything together and convenient. And so let's look at how that script is implemented. And the great thing of these helper libraries is that this script, as you can see, is only 46 lines long, less than 50 lines to give you all that information. And that's because it's making use of our RPC helper script or library. So we have a description, basically says what the script is, and that's for generating that NSE doc. Similarly, the output that the script does, as you can see, it basically looks like what you would get from the RPC info command. It has a few fields you have to give, like the author, license, categories. This one's in discovery because it discovers more information, and it's also in safe because it does a pretty standard function that the service was made to do. It requires a couple helper libraries, short port, and more importantly, RPC. And then we get to what's called the port rule. And basically, it would be terribly inefficient if Nmap ran this RPC info against every single port that it finds open. It's going to do no good against web servers and most other services. It only works in very specific cases. And so with the port rule, you tell Nmap that the rule is if port 111 is open, or if it's any port number and it's the RPC bind service detected by version detection, and if it's the TCP or UDP protocol, this script can handle RPC bind on both. In that case, it tells Nmap, okay, this is a port that this script is interested in, and so we run what's called the action function, which is right here. And the action function takes information on the host it's running against and the port it's running against. And here's really the key line here, where we say rpc.helper.rpcinfo This is basically our helper function for grabbing the RPC info. And we say if that failed, return an error message. And then this part is just a loop that says for each of the RPC services we found, put those into a pretty table to show the user. We do a table.sort on the results so that they're sorted. And then we do standard NSE.format output to, again, that just makes the output prettier and more consistent with how Nmap scripts normally do it. And we pass it this string of RPC results that we've generated. So it's actually, as you can see, quite a simple script, but does a pretty useful function for your scanning. So that's one script. And now I want to look at one which is a little bit more complex, but not dramatically so. Let's take a look at that script that had us so much fun, the SMB enum users. Oops. So this one we can see is 262 lines. So it's about 5 times as long as the RPC info. So let's take a look at what it has. So we start with the description again. And Ron is a very verbose person. He actually does great comprehensive and complete documentation, which is really wonderful when you're trying to figure out how a script is working. And so we go on through the description and the usage information and the output information. I was thinking of changing the output to the Microsoft stuff for the default page, but the argument documentation for the arguments that it takes. And so here it's really starting the code, and we're to line 141 of 262. So more than half of this script is documentation. So now let's get to the meat of it. Now, the last script was what we call a port rule script. And so it runs against a certain port that was found open. If there were three RPC bind ports open for some reason on the machine, it would have gathered the information for all of them. This SMB script is called a host script because it runs once per machine. And so it has what's called a host rule, which tells Nmap which hosts to run against. And in this case, it's pretty simple. It uses an SMB helper function that says get any SMB or MSRPC port from the target machine if there is one. And we check if it's not equal to nil. So if we actually got a port from the machine, if it's got no SMB ports, it would have returned nil, and Nmap would have skipped the script for that host. But if it does have an SMB port, Nmap runs the action function again. Here we have a lot of variables. And you can kind of see that even if you don't know Lua specifically, this is the same sort of stuff you do in any scripting language, and so you can recognize the variable declarations, the operators. Here we first try and gather the usernames through SAMR, which is a little bit, it's the most effective of the means of gathering the usernames from an MSRPC server. And then we also try doing it through LSA, which is not quite as effective, but sometimes you can't get them through SAMR. We take these results and then we format them again. We're kind of limited on time, so I'm not showing like each line, but we format them, we sort them. Ron did a smart thing in that he breaks them up by domain. So if a domain controller, there could be several domains and you can get them listed by each. We check. This is all more formatting, you know, all those different extra information we got, like the people's full names and nicknames and password details. It's doing all that. If you're in verbose mode, it's still creating the response. And then finally, we get this final line again, which says, Nmap, here's the string we formatted with all the results. Please present this to the user for that host. So now we've seen 2 examples of NSE scripts in basically how they're coded. And we could go on and on with that, but what actually seems like it would be more fun is to do a demonstration. David is actually one of the best script developers on the planet, and he's going to show us how you can actually write a script on the fly from scratch with hundreds of people staring at you for any mistakes you might make. And he's going to do it right now.
Thank you very much. All right, so let's prove how easy it is to write an NSE script. This is something that I think any programmer can do. Let's demonstrate this kind of on a toy example. Before I left home, I set up a webcam aiming out at the beautiful city of Denver, and I want to try and see that webcam picture. The problem is, it's on my standard home internet connection, and it's on a dynamic IP address, and I don't know exactly what the IP address is. So let's write a script to find it. Before I left, I found out a couple of attributes of this webcam that'll help us fingerprint it. It serves a file called cam.jpg. The server is HTTPD, and I found that that's enough to reliably find this webcam. So we're just going to open up a file. The customary file extension is .nse for scripts. Script has to have a description. Categories for this script. It's a pretty safe script because we're not doing anything weird with HTTP, and I would also put it in the discovery category. Port rule, this is what decides if the script is going to run. Here we just want it to run for HTTP ports, so this is going to be a simple rule. Return port.number equals 80. See, Lua is easy. Now the action function, this is where things really happen. Now since we're going to be using the HTTP functions, I have to go back and we're going to require the HTTP library. A local variable here for the HTTP response. Response equals http.get host port. We want to retrieve the file cam.jpg. And now we want to test if this actually works. So we're going to say if response.status and response.status is not equal to 404, right? Because that's no good for us. This is how you say not equal to in Lua. And response.header, we can query the header values. So we're going to look for the server value here. First we're going to check that it exists, and then we're going to check its value. String.match is a standard Lua function. And we're going to match it against the pattern THTPD. Then it's real easy to return results from an NSE script. You just return a string. Oops. And so this is it. In case we don't find it, we just return nothing, and that's going to make the script remain silent. So let's give this a try. I'm going to run an Nmap. I'm going to run this script, and I'm going to add a couple of options that make this scan faster. So pay attention here. You might learn some tricks in case you have trouble with the speed of your Nmap scans. We're going to turn off reverse name resolution, turn off ping scanning. We only want to scan port 80. I only want to see hosts that have an open port. We want to run the script HTTP webcam. The ISP's address space is what I want to search here. Let's log the results to a file just in case it scrolls off the screen. And finally, this is a good tip. Always add the debugging flag when you're testing your NSE scripts, because that way when you have a syntax error or something, you'll get a backtrace. As if. I mean, we're just testing this out for the very first time in front of a room full of people. What could possibly go wrong? Give this a try. Okay, so Nmap is fast. Let's open up the results file. Webcam found. Excellent. So we found it at 66.7.171.5. And that's all there is to it. Oh, you want to actually see the webcam? All right. Yeah, sorry. I did check to make sure this would work, but... Huh. Okay, so we have a little problem here, but let's not be daunted. To an Nmap developer, there's always a solution. The solution usually involves doing more scanning. So let's do this. Here's the game plan. Are you with me? So let's start again with the description. Guesses HTTP passwords. All right, so we can't really justifiably put this in safe anymore. I want to require, again, we're going to need the HTTP library. We're also going to bring in our username password database library, because that's going to do the hard work of password guessing for us. Port rule is going to be exactly the same. Action is going to be a little bit different. We need some local variables here. We need a usernames iterator, a passwords iterator. We're going to need an additional status variable. Okay, so obviously, I know what this is going to look like, but if you don't know how to write these iterators or how to use them, this is all in the online NSE documentation. This is all outlined for you. So now this is simple. We're just going to write a nested loop here for password in passwords do, for username in usernames do. Again, we want a local variable for the response. Okay, we want to retrieve cam.jpg, and now I'm going to pass an additional parameter here with some extra options. I want to pass our authentication information here. All right, so what are we looking for here now? If response.status and response.status is not 401, because 401 means authentication required, then return username, ... is string concatenation, and we're going to end the username loop, something you have to remember to do. This is the only really tricky part of this script. You have to remember to reset that username iterator. And finish off the action function. So let's give this a try. I'm going to run a very similar command. We don't need to log to a file because this won't produce that much output. We found out the last octet was 5. This doesn't matter much for here. Oh, and remember to change the name of the script. We want to run the brute script. And go. Those of you who have done this before know that password cracking tends to take a long time. So to help pass the time, let's instead look at some of the documentation for this username password database. And kind of explain what's going on here. So if we go to look at the documentation for this library, we get a description here. You see this little trick of using reset to reset the iterator. It tells you about the default timeouts. These iterators don't run forever. By default, there's a time limit. So these scripts will eventually end even if they can't guess the password. It depends on the Nmap timing level. It tells the format of the data files if you have your own username or password lists. It tells you the script arguments so you can control how these iterators work. So for example, UserDB, if you have your own username database, you can control how many names are guessed. Password database. And here's exactly what I referred to. This should look very familiar because this is basically what I just wrote in the HTTP brute script. The doubly nested loop, resetting the iterator. I mean, this is the documentation I referred to when I was preparing to write this script. And then a list of the functions that come along with it. You saw that we used the passwords function and the usernames function. And there are a few other that you can get access to if you want. So let's check on this. Oh, it finished in 60 seconds. And oh yeah, butterfly. That's the password I use for all my accounts. I should have known. So let's give it a try here. Web, butterfly, and there she is. Looks like it's raining in Denver. So this was a script written, under time pressure in front of an audience. I had to cut a few corners. Let me explain to you what I would do, what additionally I would do to the script in order to make it suitable for being included with Nmap, which I hope it is. We should have an HTTP brute script soon. The port rule should be expanded. Just matching against port 80 is lame. We should match against port 80 and the other common HTTP ports, as well as any ports that Nmap's version detection has detected as HTTP. So I would use a short port library to make that very easy. I would add script arguments so that we hard-coded cam.jpg. I would add a script argument to control that. I would add more documentation for usage and output. And finally, this is important, I want it to be able to cache these credentials in the registry so that scripts that run later through our dependency system can use them. So for example, if we ran this HTML title in conjunction with HTTP brute, HTML title should run second, and it would give you the title Denver Cam instead of the title 401 unauthorized. Let me turn it back over to Fyodor now, and he'll tell you what's coming up next in NSE.
All right, thank you, David. So here's some new things that we have in mind for NSE. And this isn't some pie in the sky, maybe we'll do these some year or not sort of thing. These are actually things we're working on now and hope to have within the next month or so. One of them is called pre-rules and post-rules. We've seen so far that Nmap, we've seen two types of NSE rules. We've seen the port rules that run against a particular port, and we've seen the host rules that run against a particular host. These new rules, the pre-rules, will run before the scan even starts, and the post-rules run after the scan is done. Now here's kind of our ideas for what you're going to do with those scripts. Pre-rule might be useful for scripts like, say you want to do a DHCP server broadcast request to try and figure out, what the network you're on, what the net mask is, what sort of IP addresses it's assigning. That's not something you want to run against every target host. That's something you want to do once at the beginning and print the results. Similarly, you might do a broadcast ping and print out all of the machines that respond to this sort of ping. The post rules you might use for reporting. For example, Nmap normally shows you every host one at a time and all the ports open on that host, but you could write a post rule script that does a reverse index and shows you like one port, say SSH on port 22, shows all of the hosts that have that port open, so you can then run a SSH related command against all of them. The next feature is called target acquisition scripts, and it actually ties into what I just talked about before. What if a script like that DHCP discover script could then take that net mask and network that it got from the DHCP server, instead of just printing it out, what if it could hand it to Nmap to let it do further scanning with? What if the broadcast ping script could take all of the machines that respond to a broadcast ping, pass that to Nmap, and do whatever sort of scan you requested? And so I think having both of those together, they'll be very synergistic and make it more easy. Zone transfers might be another one. You could have a pre-rule script, which you give it a domain, it finds the authoritative servers for that domains, it tries them all for zone transfers, and then can either print the result, or you can tell it just pass the results directly to Nmap for further scanning. We also have a lot of scripts in the queue. Like I said, we're always growing there. I'm not going to discuss them in much depth, but there's a VNC information script, a brute forcing script for VNC, a subversion brute forcing script, a host map script that says for the IP you scanned, it actually uses a third-party database to say, here's a bunch of DNS names that resolve to this particular IP. So for example, a web hosting server, you can kind of see what all it serves. The HTTP XST is a cross-site tracing related detection script. And we have some libraries in the queue too. One more thing I wanted to show off because it's pretty neat. There's a lot of new stuff in NSE, and we don't have time to look at too much of it, but I do want to show you a script related feature, which was going to be in the upcoming features until yesterday when we checked it in. And so we don't have to be root to use this. Nmap pops up, and with the scripting, you saw that there's a whole lot of different scripts. They take a lot of arguments. If you're a real Nmap command line wizard, you can do it through there. But sometimes it can be easy with Nmap's profile editor. We added a new scripting tag, which shows you all the scripts that are available to run. Let's look at one like NFS-LS that we talked about before. We click on it, and it shows us the description of the script over here. It shows us the different arguments that it could take. Like we'll stop at the max files and say we only want to show up to 10. And then you can see how it has filled that in to the nmap command up here. Similarly, we'll say we want to run this script and this script and this script. And again, it kind of gives you the exact command that you want to use, which can be useful at times. Oops. Oh, here we go. And now I have some really, really brief Nmap developments and news I wanted to share. We have about 6 minutes left, so I'm really going to shoot through these really quickly. But there's some neat things that you guys might want to look at in the future. Here, for example, a tool that not as many people as I think should recognize exists and how easy it is to use. It's a simple concept, but the idea is NDiff takes 2 scans you've done, maybe one day and one the next, and shows you the differences between those scans. What new hosts are up, what new services are available, what services have changed version number. Here I did a whole scan of Facebook's network on July 24th, so a few days ago, and then one on July 25th of the same network, and I look at what changed. Here we see they changed some light HTTPD servers to NGINX server. We see this legacy mail system changed a little bit. And from there, from your baseline of your network, you can really get a good eye on what has changed very easily. In the Facebook case, it would be a pain for me to do this scan every day, do the diff manually. So this is how simple as cron job it takes in order to do this. All I do every morning, this script runs. It does a scan of all of Facebook's IP addresses, and it compares that to the scan it did the previous day with NDiff, and it prints out the differences as well as the full scan results, and then cron mails me the data, and I can look over it and see what they're up to. Another tool I wanted to talk about is NCAT. How many people here are users of Hobbit's original netcat? Okay, again, pretty much everybody, because it's a darn useful tool. And you might wonder why it is that I would bother even re-implementing such a tool. The problem I saw was that Hobbit's networks have changed in the past decade, but the original netcat hadn't. I understand that Hobbit decided that he wanted to do concert tour stage lighting and hang around with rock stars. Some people think that's more fun and glamorous than staying at home debugging network code. Obviously, I disagree. And so we did NCAT, which gives you features like SSL encryption support, proxy support. It can be a proxy server or proxy through several servers. It's portable, port redirection, IPv6, better access control, a neat feature called connection brokering. One feature that it still is missing, it doesn't have the port scanning feature of original netcat. I actually have another tool I like to use for that. nping we're working on, and this is sort of a ping tool like your normal system ping or hping3 or whatever, but again, added some features that we really wanted to see. One of the most exciting, and that we have code working right now in our experimental tree for, is called echo mode. And what that does is with normal ping, you may ping the system and get nothing back. What was your packet dropped on the way there? Did the system receive it but not respond? Did it get dropped on the way back? With echo mode, you run or you tell the person you're debugging with to run nping in echo server mode on the other system, and then you nping it, and it shows you right in the nping line, along with the sent and received packets, it shows you the captured packets received on the server. So you can see, oh, was there network translation involved that changed the IP address or port address when it got to the server? Did it get to the server and then it was the response that was dropped? It's really a neat little tool for network debugging and understanding. We have a tool called ncrack, which is a network authentication cracker, which for SSH, for example, it really shines on in cracking that very quickly. And we have a Google-sponsored Summer of Code student named Thilgor, who's right now within days of finishing the RDP cracker, which is great because that's a protocol that traditionally there aren't very many tools which support. By the way, nping is by a guy named Louis Martingras, who's another Google-sponsored Summer of Code student. And a third Summer of Code student is working on Nmap, an online scanning service that you can use to say, oh, scan my network every day and send me alerts of the differences that you find. And it's a handy thing. Finally, I wanted to mention the Nmap script authors. Basically, sometimes I get way more credit than I deserve just because I wrote Nmap 13 years ago. But really, it's a true open source project, and the only reason it's anywhere near where it is today is because of contributors by a wide number of people worldwide. So this is the list of just the people who've written NSE scripts, and it's just a small subset of the list of people who've contributed to Nmap in total. Final notes, Ron Bose, the SMB, the writer we already talked about who did the SMB scripts, and today he was on Slashdot for basically downloading all of Facebook's profile names. I think he got 177 million of them. He's going to be doing a Blackhat arsenal to talk more about NSE scripts, and he has some cool demos planned, and it's tomorrow from 8 a.m. to 12:30 at Station 5. So I hope people will come and take a look at what he has, and he can answer any NSE questions you have. We're going to post the slides for this on Friday at insecure.org/presentations. As soon as we get the video, we'll post that too, and the URLs for downloading Nmap. So with that out of the way, we have about 1 minute for 1 or 2 questions. Who's got a question for us?
Yeah.
Go ahead.
Does the author rate the scripts? Because what if they're wrong? They don't know what they've created is a really bad script and they rate it as safe.
Yeah, we have to review them very carefully before putting them in.
Yeah,
so for the rest of the questions, you can kind of come up here and we'll talk with you more. For everyone else, thank you for coming, and